To start today's episode, these are the 5 wonder tips for you to remember to keep your back, neck, and eyes healthy while indulging in some screen time. This is Teacher Melvin's healthy tips for everyone. Number 1. Sit properly so you are well supported. Your back should be touching the chair backrest. Number 2. Change your position regularly. If you are watching for long periods, take turns sitting on the couch, chair, or floor. Number 3. Keep dim lighting on in the room rather than no lighting. Strong or no lighting may lead to eye damage over time. Number 4. Stretch. Use commercial breaks to change positions, to get up and walk around, and to do gentle stretches. Number 5. Don't watch TV in bed, as this often leads to neck and backache. There! You are now ready to begin.
Katanungan sa ating isip ay may kasagutan. Para magtungkol sa agham ay makakamtan. Wonder sight ang ating kaglapan. Agham o siyensya, kadugtong ng ating buhay. Agham! Siyensya! Halina't mag-aral na siyensya ating alamin. Agham o siyensya, kadugtong ng buhay.
Hello, Wonder Warriors! It's me, Teacher Melvin, your companion to your Wonder Science Adventures. Learn everything under the sun because here at DepEd TV, Grade 10 Science is fun. So buckle up and get ready to power your mind. This is Wonder Science! Congratulations, Wonder Warriors! You have successfully completed 9 episodes of Wonder Science. As a prize, I will give you a Wonder Badge. We're now on our 10th episode, the last one for this quarter, and it has been a wonderful experience with you all. From our explorations, you learned many things and were amazed by the wonders of science. So brace yourselves for another journey here in Wonder Science. Last episode, you learned that Alfred Wegener's curiosity drives him to look for evidence that supports his continental drift theory, that continents were once connected as a big landmass called Pangaea. It is worth to note that the continental drift theory is being supported by the following evidences: continental fit, matching of rocks, fossils of ancient organisms, coal deposits in Antarctica, ancient climates, and glaciers carvings. But did you know that despite Wegener's gathered evidence supporting his idea about drifting continents, during his time, the scientific community rejected him for some problems? Interesting, right? Nevertheless, Alfred Wegener didn't give up and continued his expedition to search for more evidence, but later on, he died. That's quite a sad ending of the story, right? In fact, it took many years before his theory of continental drift was accepted. So now, imagine yourself standing in front of Alfred Wegener. If you are to ask him questions about his theory, what will it be? Come on, don't be shy. What is it? You probably ask him these questions. What causes the continents to move? And what can other missing indications be used to support such a claim? Let's find out in the next theory, which we will explore together in this episode. Remember, you learned from the previous lesson about the continental drift theory that all continents were once connected into a big landmass called Pangaea. And this was supported by the pieces of evidence gathered by Alfred Wegener. However, questions such as what causes the continents to move was not logically answered by the theory. In this episode, you will learn about the seafloor spreading theory that will strongly support the idea that continents are drifting and find out the site of origin of plate movements. To start, please prepare the following materials: pencil, piece of paper, and your self-learning module. Take note of the important details that we will explore. Remember, by taking notes, you can easily recall our lesson. To start, focus your attention to this figure. What do you see? The idea of continental drift circulated in scientific circles until World War II, when sounding gear called sonar, short term for sound, navigating, and ranging, produced new evidence of what the seafloor looked like. The gear, developed in 1930s, bounced sound waves off the seafloor to determine its depth and features. Sonar uses sound waves to see in the water. It is helpful for exploring and mapping the ocean because sound waves travel farther in the water than do radar and light waves. NOAA scientists or the National Oceanic and Atmospheric Administration primarily use sonar to develop nautical charts, locate underwater hazards to navigation, search for and map objects on the seafloor such as shipwrecks, and map the seafloor itself. So how did the sonar help in formulating the seafloor spreading theory? Well, it all happened when the command of one attack transport ship, the USS Cape Johnson, was given to Harry Hammond Hess, a geologist from Princeton University. Hess, then in his late 30s, wanted to continue his scientific investigations even while at war. So, he left his ship's sounding gear all of the time, not just when approaching port or navigating a difficult landing. What Hess discovered was a big surprise. What did Harry Hess and his men accidentally discover when they explored the oceanic floor? Were they able to locate the start of all the movements on the Earth's surface? Moreover, did Harry Hess' team gather much strong evidence to support the claim that continents are drifting? To answer these questions, let's continue the story. Ocean floor exploration continued, and by the 1950s, other researchers had found that a huge rift ran along the top of the mid-Atlantic ridge. That enabled Hess to understand his ocean floor profiles in the Pacific. He discovered that the bottom of the sea was not as smooth as expected, but full of canyons, trenches, and volcanic sea mountains. He realized that the Earth's crust had been moving away on each side of oceanic ridges, down the Atlantic and Pacific Oceans. Harry Hess observed that the rate of formation of new seafloor at the mid-ocean ridge is not always as fast as the destruction of the old seafloor at the subduction zone. In the early 1960s, dating of ocean core samples showed that the ocean floor was younger of the mid-Atlantic ridge, but progressively older in either direction, confirming the reality of seafloor spreading. Now, here's a little trivia. The process of subduction and seafloor spreading can change the size and shape of the oceans. Because of these processes, the ocean floor is renewed about every 200 million years. That is the time it takes for new rock to form at the mid-ocean ridge, move across the ocean, and sink into a trench. Did you know that the vast Pacific Ocean covers almost 1/3 of the planet, and yet it is shrinking? How can it be? Sometimes a deep ocean trench swallows more oceanic crust than a mid-ocean ridge can produce. Then, if the ridge does not add new crust fast enough, the width of the ocean will shrink. In the Pacific Ocean, subduction through many trenches that drain the ocean is occurring faster than the new crust can be added. On the other hand, the Atlantic Ocean is expanding. Unlike the Pacific Ocean, the Atlantic Ocean has only a few short trenches. As a result, the spreading ocean floor has virtually nowhere to go. In most places, the oceanic crust of the Atlantic Ocean floor is attached to the continental crust of the continents around the ocean. So, as the Atlantic's ocean floor spreads, the continents along its edges also move. Over time, the whole ocean gets wider. Interesting. This explains why the Pacific Ocean is getting smaller and why the Atlantic Ocean is getting wider. If the subduction zone is faster than the seafloor spreading, the ocean shrinks. Here's another trivia. Did you know that because of seafloor spreading, the distance between Europe and North America is increasing by a few centimeters per year? Well, that's more interesting. I hope you're doing well and staying healthy as we explore the next theory that will support the movement of the continents. This time, let's talk about magnetic reversal. Further evidence came along by 1963 as geophysicists realized that Earth's magnetic field had reversed polarity many times, with each reversal lasting less than 200,000 years. Rocks of the same age in the seafloor crust would have taken on the magnetic polarity at the time that the part of the crust formed. Sure enough, surveys of either side of the mid-Atlantic ridge showed a symmetrical pattern of alternating polarity stripes. Have you seen a magnetic compass? As we all know, a magnetic compass can tell direction. The needle of magnetic compass usually points to the North Pole of the Earth, which is actually the South Magnetic Pole at present. The crystallized irons in rocks found in the seafloor act as a magnetic compass that can tell the Earth's magnetic field direction. So what exactly is magnetic reversal? And how can magnetic reversal be used as evidence of the seafloor spreading theory? Let's find out. Seafloor spreading was strengthened with the discovery of the magnetic rocks near the ridge following a pattern aside from the fact that the rocks near the ridge are younger than those farther from the ridge. Now, focus to this figure. What does it show? This shows the symmetrical patterns on each side of the mid-oceanic ridge. Magnetic reversal happened many times in the past. The occurrence of the magnetic reversal can be explained through the magnetic patterns in the magnetic rocks. These magnetic patterns allow our scientists to understand the ages and rate of movement of the materials from the mid-oceanic ridge. The magnetic reversal, also called the magnetic flip of the Earth, happens when the North Pole is transformed into the South Pole and the South Pole becomes the North Pole. This event happens because of the changing direction of the flow of materials in the Earth's liquid outer core. Over the last 10 million years, there had been an average of 4 to 5 reversals per million years. New rocks are added to the ocean floor at the ridge with approximately equal amounts on both sides at the oceanic ridge. By the 1970s, geologists had agreed to use the term plate tectonics for what had become the core paradigm of their discipline. They used the term plates because they had found evidence that not just continents move, but do so the whole plates of the Earth's crust. A plate might include a continent, parts of a continent, and/or undersea portions of the crust. So there! You have just learned about seafloor spreading, and since there are strong evidence that continents are drifting as supported by the continental drift theory, seafloor spreading, and magnetic reversal, can you predict the next movement and locations of the continents 100 million years from now? And is there a possibility that another supercontinent might be formed? As your final output of Module 5, I will ask you to perform this activity titled Pangea Ultima, or the Last Supercontinent. For this activity, please refer to your self-learning module and prepare the following materials: pencil, coloring materials like crayons, short bond paper, and a world map showing the present location of the continents and their movement. This will be our key guiding question. How does climate change relate to the movement of continents? To answer this question, let's do it this way. I would like you to focus your attention to this map. It shows the present location of each continent. The arrows indicate the direction of each plate boundary or continent. If you can speed up the time 100 million years from now, predict what will be the location of the continents. Will they merge into one supercontinent? Your output in this activity will be rated by your teacher according to the following criteria: accuracy of details and information, 5 points; techniques, 5 points; neatness of work, 5 points, with a total of 15 points. Also, as an extra mile, answer the following questions. What can you say about the climate of the supercontinent? Do movements of continents play an important factor in the so-called climate change? Will this new supercontinent be inhabitable for mankind? Just for fun, if you can name this supercontinent, what will it be and why? Great job for finishing this module on evidence of plate movements. You are now ready to move forward to the next module. But before that, let's evaluate what you have learned so far from our lessons. Challenge yourself to do this 5-item quiz. I will read the question and choices once. You're only given 5 seconds to write the letter of the correct answer for each question. You will be given 1 gold coin for every correct answer. Are you ready? Wonder Warriors, let's play Science Pop Quiz. Question number 1. What can you say about the ages of oceanic crust near and far from the mid-oceanic ridge? A. Oceanic crust is younger near the ridge but older far from it. B. Oceanic crust is older near the ridge but younger far from it. C. Oceanic crust materials have the same ages. Or D. The oceanic crust does not age. The correct answer is letter A. Oceanic crust is younger near the ridge but older far from it. Question number 2. During World War II, he discovered and proposed that the origin of the plate would be at the mid-oceanic ridge. A. Alfred Wegener. B. Harry Hess. C. Charles Darwin. Or D. Albert Einstein. The correct answer is letter B. Harry Hess. Question number 3. Describe the thickness of sediments near and far from the mid-oceanic ridge. A. The sediments are thinner near the ridge but thicker as you go far from it. B. The sediments are thicker near the ridge but thinner as you go far from it. C. The thickness of the oceanic sediments near and far from the ridge is the same. Or D. The sediments are unevenly distributed. The correct answer is letter A. The sediments are thinner near the ridge but thicker as you go far from it. Question number 4. What type of plate boundary is occurring in the mid-Atlantic ridge? A. Convergent plate boundary. B. Transform fault plate boundary. C. Divergent plate boundary. Or D. Destructive boundary. The correct answer is letter C. Divergent plate boundary. Question number 5. Why is the Earth not getting bigger despite the fact that molten materials are gradually coming out from the mid-oceanic ridge? A. Because everything is being consumed in the subduction zone. B. Because of the faster rate of movement of materials from the ridge. C. Because older oceanic materials are pushed away and slowly consumed in the subduction zone. Or D. Because the rate of coming out of new oceanic materials and destruction of older oceanic crust are the same. The correct answer is letter C. because older oceanic materials are pushed away and slowly consumed in the subduction zone. Well done, Wonder Warriors! I am happy that you were able to challenge yourself to do the pop quiz. Now, let us add all the gold coins you've collected from the pop quiz. How many gold coins have you collected? For all the effort that you do, I will give you a fantastic badge. And that ends our Wonder Adventure for today. But don't worry, more science adventures are coming your way. Keep exploring and never stop learning. Always remember, science is fun for everyone. This has been your Wonder Explorer, Teacher Melvin. See you next time for another episode of Fun Wonder Adventures. Only here at DepEd TV.